In this problem, we're looking at factoring a polynomial function and then finding the solutions to f of x equals 0. Our first step is just to find all the potential zeros that would work for this function. We want to have something to start with instead of just trying to figure out a number from all the infinite numbers that we could possibly pick. What we're going to do is first identify P and then Q. So P is actually going to be this last number and Q is going to be the first number. So if we do P over Q, what are all the factors of 6? As in, here's a quick way to think of this. If I have 6 and I list all the different factored pairs, that would be 1 times 6 and 2 times 3. Those are the numbers you're going to use in this list. So we're going to just put this in order, and I like doing it in order here because it makes it easier over here. So this is going to be plus or minus 1, and we don't know if this is a positive or a negative here, and we're just generating a list. So it could be positive or negative, we're not sure. We'll figure that out later. All right, so plus or minus 1, and then plus or minus 2, plus or minus 3, and then plus or minus 6. So that's the list of all the P's over Q. Now Q is 3, so what are the factors of 3? That's 1 times 3. So that's it. So on the bottom we're going to have in the denominator 1 and plus or minus 3. Now to generate this full list, we need to come up with the combinations of these. So we're turning all of this into fractions. This is going to be 1 over 1, which is just 1. And then 2 over 1, which is just 2. 3 over 1 is 3. And 6 over 1 is 6. So I've used this 1. Now I'm going to do the same thing with the 3. So I'm doing each of the numerators over the denominator of 3. This is going to give me 1 over 3, which is 1/3. 2 over 3. 3 over 3 is 1. I'm not going to write that number again because we already have it in our list. And 6 over 3 is 2. I'm not going to write that number again because we already have it in our list. So what did we just generate? We generated the list of all possible rational zeros. Okay? Rational means they could be written as a fraction, so you're talking whole numbers or fractions. Possible as in, these are not the actual zeros, this is just the list of things that could work. And it's kind of nice that we have a list and something to start with instead of guessing. And then zeros mean they're zeros if, when we do synthetic division, we get a 0 remainder. So how do we figure out which of these are the actual zeros? We're going to go through and we're going to test them. And we're testing using synthetic division. So let's try 1. So we're going to use synthetic division now. So that was the first step, was the list of all possible rationals. The second step is synthetic. And we're going to do synthetic until we find a remainder of 0. Let's try 1. Where are our coefficients for a polynomial? That's up here. So we're using these coefficients for f of x. So we have 3, 14, 17, and 6. And we're going to skip a little line, draw a line, and let's do synthetic division with this and see if it works. Now it works if the remainder is 0. So we want 0 here. If this is not 0, we'll move to the next number. Bring down the 3. 1 times 3 is 3. That gives me 17. 1 times 17 is 17. This is going to give me 34. 1 times 34 is 34. 6 plus 34 is 40. So this is not going to work, which means 1 is not a 0 of our f of x, our function. So we tried positive 1. Now let's try negative 1, and let's just see. You don't know where to stop until one of these works. So you just have to keep working through them. But this is a lot better than just guessing. All right, we're using the same numbers, 3, 14, 17, and 6. So we're going to skip a line, draw a line, box in the last number. Let's do synthetic. So dropping this down, I get 3. Negative 1 times 3 is negative 3. Here I get 11. Negative 1 times 11 is negative 11. 17 minus 11 is 6. Negative 1 times 6 is negative 6. And 6 minus 6 is 0. Okay, we have a remainder of 0. Great, so that means, let's write down what we know. We know that we tried negative 1 in our box, and we got a remainder of 0. That tells me that negative 1 is a 0 of the polynomial. A lot of 0 terminology around here. How do I take this 0 and turn it into a factor? So if we have negative 1 as a 0, the factor is x plus 1. So you're saying x minus whatever your 0 is. And we have minus negative 1, which would make plus 1. So this is a factor. What else do we know? Well, we have numbers here that we have like left over. What do you call that? Well, these numbers right here are called the quotient. So we know that our quotient is what? Our original function had x cubed. So we're going to write the quotient using x squared. So this will be 3x squared plus 11x plus 6. So we have a factor and we have the quotient that we got out of the synthetic division. What we want to do now is rewrite f of x. So let's rewrite f of x using what we know so far. So f of x is the factor that we found, which is x plus 1. And then we're going to multiply by the quotient that we found, because that's our remaining factor. So if I pull out this x plus 1 and I factor it out, my quotient is what's remaining after I do that division. So this will be 3x squared plus 11x plus 6. Now I was told in my directions to factor this completely. This is factored completely, but this is not. This is a trinomial that we can factor. So we're going to bring down the x plus 1, and I'm going to factor this by grouping. If you know another method, go for it. I use grouping for this. So we're going to bring down the first term. We're going to add 2 blanks and bring down the last term. And then we're going to say a times c. A in this problem is 3, C in this problem is 6, so I get 18. And my question is, what are the factors of 18 that give me B, which is 11? Factors of 18, so 1 and 18, 2 and 9, 3 and 6. Which one of these sets gives me 11 when I add them together? And that's 2 and 9. So I'm going to put those here. Now, let's talk about signs. I have all positives here, so these are both going to be positive, but if they were negative, you would need to be careful there and make sure you pick the right set and have the right signs. Now that we filled in the blanks, we want to group. So I'm bringing down this x plus 1. I'm just going to keep bringing that down all the way. We're going to group these together and group these together. And our next question is, what is the GCF in each group? So what do we have in common here? X is in common, so we're dividing by x. This is going to give me 3x plus 2 plus, what do we have in common here? We have 3, and that will give me, divide by 3, 3x plus 2. And we know we're on the right track because our parentheses here are the same. Our next step will be to bring this x plus 1 down again. And our common parentheses we can put next. Doesn't matter the order here. And when I factor out that 3x plus 2, I have x plus 3 remaining. What I just found was the factored form. So I rewrote the f of x, and then, let's say, and then factor. So this is our factored form of f of x. We have x plus 1, 3x plus 2, and x plus 3. That was the first part of our directions. The second part of the direction says solve f of x equals 0. What we want to do is take this function that's factored, write the factors out, and let's set this equal to 0. So this is one of the answers. You're going to get two sets of answers here. If I set this equal to 0, I can now use zero factor theorem. So we're going to say x plus 1 equals 0, 3x plus 2 equals 0, and x plus 3 equals 0. We want to solve each of these linear equations. So I get x equals negative 1 here. I get negative 2/3, and here I get negative 3. So we started out with a function that had x cubed in it. We got 3 answers, and that is okay. That's actually pretty typical. If you have the highest exponent of 3, then you can have up to 3 answers. So you could have none, 1, 2, or 3. So 3 is perfectly acceptable. Let's list these. Negative 1, negative 2/3, and negative 3. So our factored form is this, and our solutions to f of x equals 0 are these 3. And that is how you factor a polynomial and solve for the solutions.